Hello, everybody. Welcome to Advent of Code Garden, one of our December running series. I'm Renee Neville, the Regional Cloud Advocate for Microsoft Reactor for the Australia and New Zealand region. And today I'm joined by my specialist of guests, my lovely partner, Jack Reichelt. He's the CTO of Connected Code, a sign you may have seen in my background before, where makes super cool technology to help kids engage with learning technology, and he's also a professional dungeon master. That's Jack. Thank you for joining us here today. Jack is the keenest of Advent of Code doers, so he's the obvious guest for December.
Really excited.
Fabulous. We do have one question that we have to start by asking Jack. What is your favorite plant? This is the Code Garden. We must know.
So I had to think about this. I don't know, it's hard to pick because there's a lot of really good plants, but I figured definitely right up there are cycads. We had a really big cycad in our front lawn beside our driveway growing up. I think it actually is still there, but I haven't been to my parents' house in a while. But one thing that I really like about cycads is that they're living fossils. Cycads have been basically unchanged since before the dinosaurs. They are basically just the same plant. They found a strategy, they've stuck with it, it works for them. I think that's really cool.
That's super cool. We love a dinosaur-like plant, really. Jack does love a dinosaur, so anything old school. So yeah, well, we should get started on doing some Advent of Code to get us going. Today in the Code Garden, we'll be looking at what is Advent of Code if you've never heard of it before. We'll get started with the first problem and show you what that can look like, how to get going. And then finally, we'll be just working through some of the rest of the problems. So we'll be looking at problems 1 to 5 today. And yeah, just how we went about it. And it'll be all good to, get going with the rest of the stuff. So we'll have 3 episodes of In the Code Garden where we'll be looking up, various problems over the next, let's say, 2 weeks-ish. Join us for different ones. If you're like, I'm super, whether you're getting started here today with problem 1 if you've never done it before, or you are, quite confident in it, but you get a little bit stuck when you come to day 7, we'll have tips and tricks for you over the next 3 episodes. So today we'll be using Visual Studio Code and the Python extension to be doing our coding. We are coding in Python. You don't have to code in Python to do Advent of Code, and you might want to take these tips and tricks and translate them to your language of choice. This is what we'll be using today, and we'll be using the live share extension, so Jack and I can edit on the same code base, basically. So we've got a couple of links for you so you can join in today. We've got the Cloud Skills Challenge. So we've set up a Cloud Skills Challenge so you can practice some of your Python if you need a little, refresher course, or you haven't learned it before and you want to get some skills so you can apply those to Advent of Code. There's also the Advent of Code link, which we'll go to and show you what it means in a second. And then we have the Advent of Code Garden repo for this year, which we'll be putting all of our solutions that we create during this session up in there, so you can have a look at those. Cool. So that's not the slide I thought we were going to get. But let's go take a look at Advent of Code and see what it's all about. So, Jack, do you want to tell us what is Advent?
Yeah, so Advent of Code is a series of programming puzzles put together by a person named Eric Wassel. I don't know if I'm pronouncing his surname correctly. I should have thought to double check that, but I think it's Wassel. And basically every day, much like an advent calendar where you get chocolates, you instead get programming puzzles. Each day has it's a 2-part puzzle, so you do part 1 and then part 2 builds on it, and often makes it more complicated or compounds the problem by saying, you did that thing 1,000 times, now do it 1 billion times. And so you have to think about your solution in a different way or make sure that it's efficient enough to get to the next step. But I just find that it's a really fun way to keep sharp on programming skills, particularly if you're somebody who maybe wants to brush up on your data structures and algorithms, I think that's really useful stuff. I know that I found it incredibly useful sort of when I started doing advent of code and really trying to focus on it and get as far through it as I could. I found that my confidence greatly expanded, and the kind of problems that you get asked in job interviews are really similar to this kind of thing. And so being able to do advent of code and just working through it and getting that practice makes job interviews a lot easier.
Amazing. Yeah, I believe you've said that you've had questions that basically were like identical to ones you've done in advent of code that you got to do again. Yeah.
Yeah, absolutely. I was interviewing at Atlassian, and one of the questions that I got asked was pretty much verbatim from Advent of Code this year, obviously without the Christmas theme. But it had like, it was just the exact same problem. And that meant that I was able to really clearly like break down, how I had solved it and the limitations that I knew this solution had, and things that I hadn't taken the time to learn how to implement yet, but were things that I was thinking about. And I think that's also a really good thing to do in an interview, is discuss the limitations of your solution. Even if you don't know exactly how to fix them right then and there, be like, oh, there's this edge case and you'd need to consider this kind of thing. I don't know exactly what the solution would be, but I think it would take some thinking to solve that edge case, but I do know that it is an edge case, and that's a really useful skill to be able to do even if you don't have the solution right then.
Absolutely. Yeah, just having thought through these kinds of algorithms is super useful, being like, how can I manage all of this data and solve this problem, and like take something that is in the form of words, and a lot of the problem is in interpreting what it says. So I guess with that, we should go to the first puzzle. So I'm going to bring that up. So I'm bringing up one that I haven't solved. So this is my new account for joining in, and I'm going to go to Advent of Code, and then we can see here that we've got 5 puzzles unlocked, and we've got just 4.5 hours till the next one comes and becomes available. So yeah, this is our first puzzle here. We'll give you a little overview. We'll describe it to you, but we won't read the whole thing out. But yeah, basically we can see the puzzle here. We can see some examples of what it's like, and then we can get our own puzzle input. So people get unique, or like one of many, I'm not actually sure, puzzle inputs that you can collect your puzzle input and put it into a file, and then you're going to run your code that you write on your own puzzle input and get an answer that is specific to you. So you can't just copy our answers and get all the points. You have to run the code and get your own text file to run that on at the very least. So yeah, Jack, you want to give us an overview of what this problem is about?
Sure. So the day one problem for this year is, and for most years, tends to be, let's read some numbers from a file and manipulate them in some way. Every advent of code has a bit of a story. You're always saving Christmas in some way. One year Santa accidentally dropped his keys to the sleigh into the ocean, and so you had to get in a submarine and repair the submarine and keep it running as you went down, find the keys, navigate the dangers of the deep ocean, and make your way back up with the keys. Or you need to make sure that all the toys get built on time. Or one year you finally decide to take a vacation from saving Christmas, but everything goes wrong in your vacation. You need to fix everything. This year, we need to make sure that the reindeer have this magical star fruit that they need in order to fuel their 24-hour long light speed journey around Earth, to make sure that everybody gets all their presents. So for this puzzle, the file that we have, if we scroll down and have a look at that, is a list of numbers, and these numbers are the different calorie values of all the different snacks that the elves are bringing while on their journey to go and collect the star fruit. So each chunk of numbers, so if we see the top chunk there as 1,000, 2,000, 3,000, that's what one elf is carrying, and they're carrying a total of 6,000 calories. And we can see the second elf just has a single item that is 4,000 calories, and so on. that code block there with the numbers in it, that's what we have as the example input for our program. One really useful thing when you're writing Advent of Code programs is to copy that input out and make sure that your program works for that input. They often have edge cases that they deliberately don't quite hit on, so you might need to think a little bit more about the problem rather than just solve it for exactly this case and then move on. But I find it's really useful to have like my program as a Python file, and then I have test.txt and data.txt. And those are the two files that I read in to get my input based on whether I think I've solved the problem or whether I'm still working on it.
Yeah, awesome. So yes, this is part one of our problem, and when we finish this one, we will get our second. We'll first get a gold star, and then we'll move on to part two. Having mentioned that, so we are collecting gold stars. We do want to get all the stars if we can make it 3 days, up to 25. I've never actually gone through and done all of them. They get quite long by the end of it. Jack has, however, done them. He's put in a considerable amount of time to get all the way through.
Last year, I finally beat all 25 days of Advent of Code. It did take me until about the 7th or 8th of January, but I got there eventually.
That's it. It's all what's it about. You didn't have to get it by Christmas. It's holiday time.
Exactly.
But yeah, I'm going to mention.
We've got other things to do, food to eat.
Exactly. We've got like statistics and stuff here, and we'd like to invite you all to join our private leaderboard. So you can set up your own private leaderboards. I've created one for Advent of Code, and you can for the Code Garden, and you can join with this code that's currently on the screen. I think Sarah will drop it in the chat for us imminently. And yeah, then you can all join in. I'll also put this. It's also in the repo, the code. If you go to Advent of Code, the Advent of Code Garden 2022 repo, it's there on the README. And yeah, you can join us, and we can all see how it's going for everybody else and see where you're up to. And if you're it's a little bit of a race. So the sooner you finish it, the higher you go on the leaderboard. But it's just about seeing who's going along and coming on our journey. So yeah, Sarah's popped that in the chat for us. Let us go and start the problem, I reckon. So that is our code. Mm-hmm.
The only thing we forgot to mention is what we're actually trying to get out of this first problem. We talked a lot about tips there.
Yes.
But what we're trying to do is find which elf is carrying the most calories and how many calories are they carrying.
Yeah, cool. So I guess, we're taking we'll have our input. So our input's going to look like this. Each elf is one of these sections. We need to add up each section and work out which elf has the total, like the most, and how much is that elf carrying. So we're going to make a little program that basically digests this information and adds it all together as we go through and compare each elf. So let us get our VS Code open. I'll bring that into here. And I've gone and made 2 files already. So we're here in our Advent of Code Garden 2022 folder in the Microsoft Reactor repo. So you can all access this. I've made 2 files. I've made one .py file. Let me just clear some of these extra bits. I've made a .py file and called day one, and I've made one called day one / data txt. So that way I'm going to put my data in there. So I'm going to pick this all up and copy it into there. So it's handy. You might also want to create one called day one example. Actually, let's do that because it's just easier to have another one. And that way we can test it on the little one, make sure it matches the answer they've given us, and then we can keep on going and do it on the big one. And then sometimes there's a little edge case in the big one that's not in the example, as Jack was saying, but you're on the right track at the very least. So let's make another file called example. Cool. We've got that. I'm just going to copy that code in there. I've wandered away from the page we're on. Okay, cool. So I'm also going to set up the live share so Jack can also edit this.
Yay.
Participation. And then we can also, I think the great thing about the live share is like one of us can be writing code, the other one can be writing comments. Super, super cool, I think. I've put this in the wrong file, so I'm going to take that out and put it where it belongs. Okay, we're set up and we're ready to go, except for the live share. So I'm going to click this little live share button. This is super cool because you can just share a link, and I'm not signed into GitHub. This is, okay, interesting. Give me just a minute. I've updated my operating system recently, so it's done some things, and every time you hit it going around another corner, you find something that you're just not logged into again. Okay, now I'm going to make this all work. Cool. Do you want to start describing, Jack, how you would approach this in terms of the first step in the data?
Sure. So the first thing that I think of when I see this data is that we've got these blocks of numbers where, yeah, as we can see here, each elf is separated by an empty line. I think probably my first thought there would be, let's split this up into all the items that each elf has. So I'd be thinking about, okay, well, let's maybe read the file and then pull in just the, not the blank lines, but split it up. And so then instead of having one big long list of lines or one big long text string, we've now instead got a list that has each elf's stuff. And once I'm in, I have a piece of a little snippet of code that I find is really helpful for just getting the getting all the lines out of a file in Advent of Code. I like to do this because almost every Advent of Code problem starts with reading some text from a file in some way, shape, or form. And so it helps to get in every line, make sure that you've trimmed the white space, make sure that you've split it all up into its individual lines and everything. So once I have
You've
joined
got that
the
link,
live
so
share,
click
which
it.
I'm joining now, yep.
Fabulous. Okay, Jack's going to give us some data eating code.
Yeah.
So we've got our example. So we'll start off with our example text first. Yes, every afternoon at 4 o'clock Australian Daylight Savings Time, Jack and I are like, oh, let's do it. So yeah, we make a little bit of a race.
I have an alarm set for 3:55 so that I can go and make sure that I'm set up and I don't have anything else going on. We're all
and
keen.
This code Jack is about to give you is often something he's got set up before 4 o'clock because we know we're going to be doing some sort of data munging activity. So are you in, Jack?
It's thinking about it. It's loading.
Okay.
So
I'll start with some codes. We have something to talk about.
Yeah, or I've just put in the little studio chat between us, the
great
block of code that I used for day one.
Terrific. Okay. Yours has a sensibly named variable. Oh, okay, cool. Jack's gone and done a list comprehension. So this is a harder way to do it. If you're doing it for the first time, you don't have to do what Jack's done. I have used a little loop for myself just because I just think that's easy. So yeah, but in this line, I'm going to give you 2 parts of code so we can see what we're doing.
This is definitely a piece of code that I've used on basically every Advent problem I've ever done. And so I shrink it down. I've made it nice and small because I don't want to take up a lot of room and I don't want to think about it much.
Yeah, so Jack has done what we call a list comprehension, and it's basically a loop that spits out a list. And what it's doing is it's opening the data file. Then it's reading that file just as one big blob of text. And then it's going to split it on the new line character. So if we go to here, with the 2 new lines. So we've got 2 new lines here. So it's going to split it into each elf chunk. So we're going to get 1, 2, 3, 4, 5 for that one. Then for each of those, we're going to strip off any extra white space on the end because we just want no extra spaces or anything on the end. Yeah, and that means we've got that ready for each of our elves.
We have a request to make the font size a bit bigger, Renee.
Oh, absolutely. Here we go. I hope that is better for you all. Okay, cool. Let's get rid of this as well. Terrific. So we've got that in a simpler format. We can have Yeah, basically we've got the same thing written in two different ways here. Are you doing any splitting of your elves yet on that one? No.
Yeah, so if you can see the split, I'm actually splitting on a double new line.
Yeah.
And so that means that this array that I get out at the end will have both, will be an array where each element is all of that text exactly.
Yeah.
Like that.
So yeah, we still need to split up each of these sections so we can address these numbers separately. So
Yes.
yeah, but let's leave it with Jack's one. So this 2-line thing is the same as Jack's 1-line thing here. I will leave this one here, but I'll comment it out. So if you're like, no list comprehensions for me, please, you didn't have to have one. Cool. So on to getting the calories for each elf. Do you want to show us what you've got, Jack?
Yeah. The Visual Studio Code's being a bit tricky. So once again, I'll dump in our studio chat my code there.
Cool.
And you can have a look at that. But I'll pull that up in a second.
Cool. Another list comprehension. I'm actually going to drop mine first, so we have an understanding before we go into the list comprehension. And I do love a list comprehension or a dictionary comprehension, but just while we're getting started, especially on the first day of Advent, you don't have to go so fancy if you don't want to.
No, absolutely not.
So here we've got cals, short for calories. It's just an empty list. And then for each elf, I just want to get the different calorie numbers. So I want to get 1,000, 2,000, 3,000 for this elf. So I have got a list comprehension where I've gone, give me that elf's data. I'm going to split it on new lines. So get these as 3 separate strings of 1,000, 2,000, 3,000. And then I want to turn each of those into an integer. So we've got that. And then I'm printing my items because I love to print things. I don't remember why now. We're several days into the competition. And then I'm just going to take a sum of the items. You can print this out. We don't need all these prints. I'm getting rid of them. And then we can
they're really, I was going to say, they're really useful when you're writing the project. Often it's very good to keep an eye on what your variables contain at each step, because a lot of Advent of code is data manipulation, and sometimes you might manipulate the data in a subtly incorrect way. Like, for example, you might forget to convert it to an integer for this one, and it might still be strings, in which case sum won't work. Or you might have an off by 1 error, less likely when you're doing a list comprehension like this, but you might have left off the last item, whatever that might be. And so everybody's going to be 1 item short, and maybe that's the item that makes a difference. Knowing how Advent of code is formulated, that probably is the case. The last item is probably significant for your answer at some point.
Absolutely. Yeah, so yeah, I do a lot of printing throughout this, and so does Jack, just to check on, like, is this what I'm expecting it to be at this stage? But here, this one's a nice, simple one for us to get started with. So I'm just going to sum up all those items that I've just put into this list. You just put a list in sum and it gives it out to you. And then we get the calories appended to a list. So yeah, but for the moment, we actually just want to get the maximum one, right? So we're gonna yeah. So we'll add them in there, and then at the end of that, I can just take the maximum of cals. I can print that out. And this is run with Python 2 for some reason, so I'm just going to change that, because we here in the future would like our Python 3 flavored. And we haven't called it data. We're going to run with day1 example.txt first. Did I misspell something? What have we done?
You've called, in the file you're reading, you've called it day1 example.txt.txt.
Pretty much txt. Day1. Give me this name. same thing?
Oh, I think it's because it's in you're running it from your reactors folder, not from the lower level.
Let's go in. Yes.
Folder.
Every time I do a many-leveled thing, I forget to move to the directory that we're in, which is, we want to go into our coding languages and frameworks, and then we want to go into Code Garden. And right, no, we did not move us. CD into coding languages and frameworks, CD into Code Garden. Great, we've arrived. Now we can run it.
There we go.
Terrific. That's our example one there. And is that what we were expecting? Oh, where's my thing gone?
I'll tell you that is what we're expecting for the example. We're expecting 24,000.
Fabulous. We've done that. Okay, so then we could just switch it over to data, and then we would run it again, and we would get this number here, which we can then find out if it's correct. Before we do that, do you have any? I'll add in your code for this problem, which is another mega list comprehension. This list comprehension has a list comprehension inside it, so not for the faint-hearted.
No, but I like it for one slight. Well, the reason I did this, you need a new line there. That's 2 lines of stuff.
Thank you. Yes.
The reason I did it this way is, well, so first of all, I really like list comprehensions. I think that they are a great way to perform the same operation to lots of stuff and ensure that you're not going to get these off by one errors of, you accidentally went to the wrong index or whatever. If you've used other languages like JavaScript or Java, then a list comprehension is pretty similar to using a map function, in that you pass in some iterable, in this case elves, and then for every element of the iterable, you perform the stuff at the beginning. So in this case, we make this other list comprehension, and then we sum that all up. And then that, and then doing the sort at the end. Once we get to part 2, I'll explain why I did the sort and why I did it this way. But we'll see that there is some benefits to that, definitely. Absolutely.
Cool. So I'm going to put this up with the other one here. They can be friends. I'm going to have that one. I'll just go with one option. So we have this option,
Absolutely.
And then we have this option here. So we've got lots of list comprehensions if we've got only the one. But you don't have to do any. You can just do it all with a for loop. So we've got that.
Sure.
And yeah, so we have our answer. Let's go and see what happens. And pop it in here. So you just go and put your answer into the answer box. See if we've done it. We've successfully got our first gold star of the challenge. And let's go on to part 2. So this is going to be an extension of the problem we've just done. So in the later weeks, you might want to be thinking about potentially what they will ask you for part 2, and make sure you're setting your code up so you're going to be able to change it easily when we get to part 2 if you're racing to do it. And that way you don't have to rewrite completely from scratch. But after a couple of years doing the competition, you kind of start to know where they might go with the second part. Cool.
Yeah.
So
if we go back to the code, I'll explain what I did that lets us do this. Oh, actually, let's explain what the problem is first.
Great idea.
The elves have realized that whoever has the most snacks actually still has a finite amount, and they might run out. So they have expanded what they want to know to who are the 3 elves. How many elves are the top 3 elves? How many calories are the top 3 elves carrying? And so if we go back to the code, this is why I did this elf_int.sort at the end. That means that all of our the total calories that each elf is carrying are already sorted. So then to finish off part 2, all I have to do is get the last 3 elements of that list. And so that makes it a lot, and then add them up. So that makes it nice and easy to get the final. Yeah, so doing part 1 in this way made it nice and easy to get the final, the part 2 answer out as well, because it's literally just that extra line of code that Renee's just added. And then if we run that.
Yeah, well, I'll just explain it first. So this is, we're doing a list splice here. You can go from the back of the list if you use minus signs. So we're saying the minus third to the third last to the end. We leave this blank of the items in the list. So then we get that and we sum it up. And so we can run that and we can get that here. So this should be our new answer. I'll also pop in the code that I use to get the final answer for part 2, which is here now. Cool. So that would basically, same thing. There's a different sorted function. I've sorted the thing rather than sorting it in place to create it. I've created a new item, but I immediately get the last 3 things and I sum it up. So same difference. So let's get that and let's pop that into the site, which is over here, to get, fingers crossed, our second star of the competition. There we go. We've got 2 stars. So if we go back to admin of code,
terrific.
We can see we've got 2 stars here. If we go to the leaderboard.
And the image has changed.
The image has changed. Good point.
Yes. So as you solve each problem, or rather as you get each star, more and more of this image will change, and it will reveal what it reveals a hidden image. And gives all sorts of interesting. It's usually just a sort of fun picture. If you go back, and I don't know if I can share previous years, but I'll see if I can share that nice and easily.
Yeah, I think like you'll have to have done it to get the previous years up. So I'll get my one from last year up, or from a year. We'll find out which year I maybe did the most in. I'll get 2021 up. Oh, yep, cool. So I did a bunch of 2021, and we can see that. Oh, yeah. So it does eventually show you the picture, after a while. But yeah, you get it colored in when you have done it yourself here. So yeah, you'll start revealing things, and and then you can have it all filled in yourself. Yeah, so that's super fun. Cool. So shall we take a look at part 2? I guess you can also look at you get your own stats for how fast you did. Go to the leaderboard and you go to your personal stats. You can see how fast you've done things, and see how many people did it before you. So yeah, this is this one we've just done now. So a little late to the party, more than 24 hours doing it. But it's never too late to start. And you can also go to the private leaderboard, which I'll join now. Then I can be on it with myself, which will be fun. So
too many Renees.
Never enough Renees. So yeah, I've joined my leaderboard, and I can go and view my leaderboard, and it will have 2 Renees. Renee.
Hey, some of you have already joined
on our leaderboard. That's so exciting. Welcome.
Hey, welcome.
And Kisam and KS. Amazing to have you here on the leaderboard. Super cool. So with that said, let's go and do the next problem.
Yeah. One thing that I'll just chime in with is the VS Code live share doesn't seem to be working. I'm not entirely sure why. I've done a quick Google, but it just sits there saying it's joining forever. So I won't be contributing. We'll mostly stick with Renee's work, and I'll just chime in and offer my thoughts as she puts her stuff in.
As we do. I think because we both recently updated our operating systems, and not everything is quite in sync at the moment. But that's okay. For our next episode on Friday, I'm sure it'll all be working. I wanted to show us adding the live share, and that was a mistake. We should have done it beforehand and just started with it. But we know how to click the button, and next time it will work.
Hopefully the button works.
It worked when I was doing with Amanda, so it definitely works. It's definitely very cool. So let's go and make a new file. And I'm going to start with day2.py, and I'm going to do day2-example.txt and day2 text. That's what I call it, data.txt. Amazing. Okay, so what is it about?
Right. So this one's about the elves are playing scissors, paper, rock to work out who gets the best tent on the beach next to their snack storage. And one of them gives you a strategy guide of how to win at scissors, paper, rock without, sorry, they call it rock, paper, scissors, without messing up, without being too suspicious. Because this isn't just rock, paper, scissors and you win or lose. You actually get a number of points based on which shape you selected and whether you lost, drew, or won. And so there is a bit more strategy beyond like just always winning or losing.
Yeah, so we need to work out, based on their scoring system, how to win. Based on the elf explaining it to us, explains some of it, but then has to run away. So we've been explained some stuff about the data. So in the data, we say the first, where is our example? This is the example here. Let's go take a look at our puzzle input as well. It looks like this. So not very complicated looking input, but it's like got all these X's and Y's and A's and B's and that. A lot of this is mapping that to meaningful language for yourself.
Yeah. So I think that this is a good puzzle to just sort of skim through a bit and show just a little bit of, rather than solve play by play, because we've only got 20 minutes left. But a lot of this puzzle is, setting up those relationships. So as we can see in these tips here, in the first round, your opponent chooses rock, which is A. In the second, your opponent chooses paper, which is B. And in the third round, they choose scissors, which is C. So for that first column, and this is explained more explicitly above, A, B, and C map to rock, paper, scissors. So it's handy to have and given that we know that rock, paper, and scissors all give you a different number of points, it's really handy to have a map, or a dictionary is the Python term, mapping A, B, and C to the appropriate number of points, and potentially even to, I did one as well, mapping them to RPS, so that I could then just compare games rather than having to compare multiple different letters and combinations and so on.
Absolutely. So shall we go and do a little bit of explaining what we've done to get this happening? Because this one was quite confusing for my brain to keep, like, especially because we've got currently that X is rock, but A is also rock for the two different players. So that, keeping that all in my brain, I was like, okay, I'm going to start by just made some like constants that were like, okay, me scissors is Z and opponent's scissors is C, for instance. So I've put all that in there. How did you go about doing this kind of part, Jack?
I went through by having a little move mapping dictionary, which I'll send to you to pop in there. Which that handily deletes all the white space. I wonder if I can give you a better thing there. Nope. Cool. It deletes all the white space. You can drop it in. It will look ugly, but basically what I've done is I've mapped each letter to R, P, or S. So then I can transform the input that we get from, instead of A, Y, now it will say R, P. And then to follow that up, later on, I have another map that takes a game. And so that takes, for example, the string RR, which is a rock playing against a rock, and maps that to a D, which stands for a draw. And so we can see here that that's a representation of all the different games of scissors, paper, rock you can play.
I've got a similar thing. Mine looks, except I've set mine up with tuples. Would have just been easy to do that. That seems entirely reasonable. But same difference where I've got ties and wins and draws, etc. And losses. Ties and draws are the same thing. So you could set up either of those.
Yeah. So this problem, and many others in Advent of Code, actually comes down to a lot of it is a parsing problem. And what I mean by that is the actual logic of the problem isn't too difficult. This one asks you to calculate the score you'll get from following the strategy guide. So you get 1, 2, or 3 points, depending on if you play rock, paper, scissors in that order. And you get 0, 3, or 6 points if you lose, draw, or win in that order. So all it wants you to do is just assess each game and work that out. And so really you're just checking a string and adding a bunch of numbers. There's conceptually, or rather programmatically, there's not a lot that's actually tricky about this problem. I am sure most of us who have joined the stream, but not everybody, and it's totally fine if you haven't. But I'm sure most of us have written a program that adds numbers based on what different strings were input. The real trick to this game comes from parsing that input. And so however you want to think about it, and you can see Renee did her tuples of her constants, and I stuck them together as strings. Those are two different solutions. That's really what we actually care about here, and that's how to get the that's what a lot of the work on some of these problems is. It's just making sure you understand what your input is and how it works and how it relates to the problem.
Yeah, a lot of it's about making sure that like the data that you need is accessible at the right times and like just easy to get to. So yeah, I did for like the scoring part that's coming up in a second, because we're basically going to go through each of those. I've just dropped in our moves into here for our example and our next our full text for us to use, and we're just going to go through all of these, and we just need to add up what the score is from each of those rounds. And that's it. So that's not very difficult. But yeah, we do want to make sure we have easy access and like make our code readable to ourselves for those, mapping the results. So yeah, when I made some little just dictionaries that map what the shape scores are and what the scores are for winning and tying and losing, just so I can say I want the tie score and I want the score for doing scissors or paper or whatever we've done here that matches to this one. So I can say shape scores me rock, and I can get the one that I should get for my score.
Yep, that's basically how I did it too.
Cool. Do you want to give me yours? Yeah, I've got all your variables.
Yeah, sure. Yeah, let me just send you a sneaky little link to my GitHub so that it's easier to copy.
I love it.
Excellent. Rather than putting unformatted text.
We don't need that.
No.
Cool, okay. We've got our move mapping.
If you copy line 43 is part 1.
Okie dokie. Terrific. So I'll just grab all of that and we can just talk through that. Cool. I'm just going to drop that all in here, and then I'm going to go here, and I'm going to just get rid of this part here. Cool. And I'm going to call this stage to example.
Yeah. So I'll give the super quick run through of this. I have my document reading line. As I said last time, this is how I do most of my Advent of Code things. I really find that that's a good way to get out all of the data nice and easily. Then I have a whole bunch of dictionaries that, as we discussed, map things like the letters to what play it is and how many points they are, and the results of different games and how many points the different results are. So that's all of the setting up and the parsing. And then down here, line 37 to 42, this is actually solving the problem. This is the bit that isn't, this was the easy bit in a way. So I just iterate through getting out their move and my move. And then I join those two strings together and make that the game string. And I put that into, and then I get out the move score from my move from it. And then I get out the game score from, or the result score from that whole game. I add both of those to this score variable. And then we have our numbers at the end. So the actual computational logic there, pretty quick and easy compared to all the time spent parsing and working out and making sure that I was getting the right numbers for the right thing and have I mapped A, B, and C correctly. And that was most of the work for this one.
Absolutely. I'll just drop mine in very shortly just to be like, yeah, I basically have done the same thing. Basically, my getting the data out and then also doing all of the processing is similarly very, very short. And yeah, we can just put it all together like that. Barely any space at all. So yeah, super compact when you've actually got it. So yeah, I've calculated my shape score and my comp score and my sum score, and then I and yeah, basically I just add those two together to make the sum score and add it to the end. So that's it. Like we've all played scissors paper rock or rock paper scissors, whatever you want to call it. And this just has a slightly different scoring metric than you would normally do for just like win versus losers, but really, yeah, quite easy in terms of the maths once we have all of our weird, lettering and stuff mapped to stuff. So yeah, let's run that.
So yeah, let's run that and get the answer out.
So 15,
and we can see
is
we
that
get
what we're expecting for our example?
No, for the example one we should get 12. Have we copied in the wrong thing or something?
No, we should get 15. We've done it.
Oh no, I'm reading 12 from part 2. My mistake.
Yeah.
We'll
get to that in just a second, Jack. You're just too excited.
Yeah.
So let's go and do our data.
Do the real data.
We get this number.
Then we get a big old score.
We pop that in.
So while Renee pastes that in, which I'm pretty confident will work.
Done it.
Great. So part 2 is that the elf finishes what they were helping with and comes back and explains that the second column with the X, Y, and Z is not your move. X means you need to lose, Y means you need to win, and Y means you need to draw, and Z means you need to win. And so now it's do the same problem in reverse. So all I did was I set up some more dictionaries instead, creating those mappings, and then working out what I had to play based on, if they played rock and I need to lose, then I need to play scissors. And so I set up some more dictionaries and then had basically the exact same loop as I had before.
That's it. So yeah, instead of mapping, I am playing scissors and you played rock and we're going to draw. Now we're saying you played rock and we need to draw, so I need to play scissors. And it's just the backwards version.
Yeah. So it definitely required another set of thinking because you had to add more of this parsing in, but it was still fundamentally just parsing and carrying on from there.
After I'd made my tuple mapping, I didn't want to do this one again, so I actually wrote code that just reversed the mapping for me because I'm like, I'm not writing that out again because keeping all these strange letters in my head, I don't know. So I'm just going to make the computer transform and make the reverse dictionary of what I had initially. So you can even do that if you don't want to be like, oh, I spent so much time saying rock and scissors and X and Y. You can just make the computer do that for you too. But yeah, so we can run that one. And I think, yes, we will get this part, which I believe is the answer. Fantastic. Okay, let's return to part 3.
To day 3. So on day 3, we're now checking all of the rucksacks that have supplies for the journeys. This is a bit of a trick. Many of you will know of the knapsack problem for computer science, but this is a sneaky little trick. This is not the knapsack problem. This has nothing to do with the knapsack problem. If you have not heard of the knapsack problem, A, look it up because it's interesting. B, don't look it up because it's not useful. Make of that advice what you will.
You'll probably need it maybe later in the competition. There's often something that's a knapsack problem disguised as something else. So if you're just getting started with this and this is your first advent or you haven't done a lot of algorithms, ignore the knapsack problem for now. And remember it later if you feel like something is some sort of packing, how much can I carry problem. But for now, you don't need it.
So as we can see down there, we have rows of a whole bunch of nonsense characters. This is the contents of each rucksack. So here we have 6 rucksacks with a number of items in them. And each rucksack has 2 compartments split down the middle. They're not marked on this string. You just have to split the string in the middle yourself. But it gives some examples of what that is. And we know from further up in the thing that exactly 1 item is repeated between each half of the rucksack here. So what we need to do is we want to find the priorities of each rucksack. So each item has a priority, and we can see just down below here, the lowercase letters have priorities 1 through 26, and the uppercase have 27 through 52. So it's just converting a letter into a number. There are many different ways that you can do that. But for each rucksack, we find out what the letter is that is in both halves, and then we add the priority of that letter to our sum total, and then we print that at the end.
Yeah.
So again, not a super complicated maths problem. We're essentially taking strings, converting them into a number in some way, and then adding those numbers up. Computationally, basically identical to the last problem, but a different parsing problem. And a lot of advent of code can be broken down into that kind of attitude of you've got your parsing half and you've got your computational half. And knowing which half is going to be the tricky half of a problem is a skill that takes practice, but also just very useful to practice.
And you kind of get an idea of how you want to store your data, because that's going to make it easy to get the stuff done. So yeah, for this one, what we want to do is we're going to take each line, we want to break it into 2 halves. So I think this is where the half line is approximately. Then we need to find the character that appears in both halves, and then we need to just turn that into whatever priority that is. So for the letter P that was repeated there in the first line, it's number 16. And then we just want to add up all of those numbers, and that's the answer we need for this part. So halve, find, number, sum. That's it. So yeah, but then we got to get the data out. So I'm going to start by setting us up with our.
So while Renee sets us up, I'm gonna give probably my number 1 advent of code tip. If you take nothing away from this stream but this, I think you've done well from the stream. Sets are super useful in both programming in general and in advent of code specifically. A set is a data type with, if you're not familiar with it, with a few special properties. The first is that every item in it is unique. So if I have a set of like my friends, and I have Renee, and I have Alex, and I have Sam, and then I get a new friend called Alex, I don't know, like I can't put that Alex in the set as well. Each thing has to be unique. So that gives us a few handy properties. One is that sets are super efficient. If you need to perform an operation on every item in a set, or check if something is in a set, those are very efficient. Compared to like, oh, I have this 1,000 element list, and I need to check if this specific thing is in it. Well, you have to check through every 1,000 until you find it. Worse if you need to get how many there are. But with a set, you just go, is this item in the set? And through a bunch of computer science on the back end that we don't have time to get into, but look up hash maps if you are interested in this kind of thing. It is the same time to look it up no matter how big your set is. If you have 10 items, it takes 1 time step. If you have 10 million items, it takes 1 time step. This is really useful because later on in advent of code, a lot of the part 2 problems are like, now do the exact same problem, but solve it like 10 or 100 or 1,000 times more. And so your solution needs to be efficient or it won't run in any reasonable time. And you can do other useful things like sets, like finding the intersection. So if in this puzzle, if you take the 2 halves and split them into 2 into sets, which you can see are lines 13 and 14 on this program. If you want to make the font a little bigger, Renee. Then those two lines take each component within each rucksack and split it into a set of items. And then I can just get the intersection, and that will tell me all the things that they both share. I then have to do some jiggery pokery where I convert it to a list and get the 0th element in order to get that out of the set nice and cleanly. But that just tells me, given that I know that there's only going to be one thing that's in both halves, that just gives me both halves and the character I need from each one. Then I have my calc priority function, which it just implements what they said there. It gives you 1 to 26 for the lowercase letters and 27 to 57 for the uppercase. And then I add that up to my sum. And as you can see, as I said before, this is basic, like lines 11 to 19. That's kind of the same as day 2's problem, right? Like, we're not, parsing a whole bunch of strings at the beginning. We're doing something a little different, but the logic there is very similar.
Absolutely.
And then I print part 1.
Yeah, so that's Jack's part 1. And it's probably the way you want to.
My part 2, I think.
Did I? Probably.
Yeah, 21 to 28 is part 2.
You can go away for now. Yeah, so that's Jack's part 1. I, however, didn't use sets because I'm like, nah, it's day 3 of the competition. It's not going to be big. It's not going to need to run for very long. So I just did the for loop way. So you have options, and that's kind of what this is all about, is like, I'm gonna put my whole function here actually. So I've called my function part 1. Because you don't have to do the fast way all the time. And sometimes you can even like do things by hand if you wanted, and just like make it easier for yourself. But I've also written a get priority kind of function. Jack's is called calc priority. Mine's called get priority. So we didn't have any conflictions here. And I've done, but a different version of that. So I've just got all the letters and I've popped them into in an order, and then I just find the spot in the list to get the thing, whereas Jack's done like getting the ordinate of a character. So all different kinds of ways to do these problems is kind of what I'm trying to get at, is like you can do sets or you cannot do sets, and like as you get further into the competition, you'll go down a specific path, because you'll probably, if you were doing what I'm doing here, which is I'm breaking the line into 2 halves based on the length, and then I'm just looping through all of the letters in the first chunk and seeing if it is in the second chunk. And if you're doing that later in the competition, that's a lot of extra iterations that you don't want to be doing on a large data set, especially if these lines were much longer. And using the sets would allow you to get that instantaneously, basically, an O1 operation, as we call it, rather than an ON, which might be, if you had N characters in a line. And we need to do it for each line. So that kind of starts to get big. But, I've gone through, I've seen if the letter is in that other list, and if it's in there, I'm just going to stop looking for the letter and then add the priority to the list. So you've got a couple options on what you could be doing there at this stage in the competition. If you're like, I haven't done sets and I don't really know how to do it, and I just want to get through the first 5 days maybe, as that's your goal, you can do it another way. Cool. So shall we run it?
Yeah.
Let's just go straight to the data rather than the example. I think we're probably pretty good.
Look, it worked for mine. Surely that means it works for every possible input.
Yes, I believe it should. Cool. So let's pick that up. Let's pop it in the site. Cool. And there we go. We've done part 1.
Cool. So part 2, really quickly, because we are pretty much at time. And we still have 2 problems to go, so I'm not sure whether or not we're going to do them or move them to the next session or whatever.
Run. Yeah.
Yeah, cool. So part 2 is we actually don't care too much about the different compartments in the bags. The elves are actually in trios, and we care about what's the one item that all people in the trio share. And so here's where using sets kind of pays off really, really nicely, I felt, in that if Renee copies in my part 2 code, Then what I've done is I go through and group. I get each group by looping through and getting every third one, starting at the initial one, plus the next two, and making its own little tuple. And then I convert them all to sets as well. And then I do the intersection twice. And just like above, that really quickly finds me everything that is shared between all three of them. And so then I get exactly one thing at the output as before. I convert to the list and I get it out, and I use the same cap priority, and I get the same, and I get the answer to part 2 nice and quickly. So that's how I did that, and that's why that's part of a big thing that I think sets let you do, is they let you pivot and they give you lots of tools, because they have all sorts of ways that they can interact with data. There's unions and intersections and differences and all of these ways of comparing multiple items, and they let you do stuff very efficiently and very flexibly.
Absolutely. So yeah, I once again didn't use a set for my second part. Mine looks like this. And it's once again, I'm just looping through and breaking when I get to a thing. But firstly, I started it off by creating all the sacks or the rucksacks, and then I've gone through and I've just gone through each third spot in my list, and then I've looked at the two after it, and then once again I've just compared. I've said, hey, for every letter in the first elf sack, check and see if it's in both of these other elf sacks, and then keep going until you find the thing and then break out of that loop. So that's another option for you if you're keen to do a loop and practice, if statements with a break. They're pretty good. So yeah, I can recommend that as a non-set based solution if you're still getting used to sets or Python and things. So yeah, let's quickly jump on to part 4. And go forward. Let us go to number 4. Did we put an answer for that? We haven't put it in, but that's okay. We'll put it in later.
No, we'll put it in later. Yeah.
You don't have to do the days in order if you get stuck.
No. So day 4 is about clearing up the camp, and each row has 2 ranges in it, separated by a column. And that's a pair of elves and what areas they have to clean. And part 1 asks us how many of these assignments exist where one pair fully encloses the other. And again, I did this with sets. I will harp on about it. I think sets are well worth learning. They're incredibly powerful and incredibly useful, because what I could do here was, if I took that range and converted it into a set of all of the numbers in that range, which is pretty quick and efficient to do, then it gives me the ability to do, if one is a subset of the other or vice versa, then that means that one totally overlaps. Every element of set B is an element of set A, and so is therefore entirely contained within. That's the trick that I did, that as you can see here, using is subset. And I just did it both ways. I didn't bother sorting, which had the bigger range or anything. It's fairly intuitive that whoever is cleaning less cannot contain all of the area of whoever is cleaning more. But sets are super quick, so I didn't bother about sorting, which takes quite a lot of time and isn't super efficient. I just said, check if it's a subset at all.
Cool. Well, I've done a different approach, and I'm going to say actually that this is potentially still a faster approach than using a set. It's my bold claim. So I'm doing the mathematical way. So sometimes you can go and Jack has created a set that has all of these different items in it, but I've just gone, well, I know where the start of something is and I know where the end of something is. So I can just compare those numbers. So that's another approach you can take to something. And at the start of the competition, when the range that Jack is using potentially isn't not very large, then it's okay to be creating big chunks of data like a set that has all of those items inside of that set. But as you get further into the competition, I would say that potentially sometimes you want to go with a mathematical solution, which is like a little bit trickier on the brain at the start, I would say, but I like math, so I've gone this way at this point in the competition. So basically I've taken each line and then I've worked out, broken it down into the two parts, and I've said, okay, I want to sort the ranges. So if we have, let's go get some of our numbers, these ranges here. So I want to get them sorted such that the one that starts first, so 2 is first in our list of items and before 6. But I also want it to go so that the one, if they had a tie, for instance, which there is not one in here, but if they both started at 4, for instance, and one went from 4 to 4 and the one went from 4 to 6, I want to make sure that the one that is in that ends last is also first in the list. So I've done a customized
The bigger one is first.
The bigger one is first. That's right. So I've done a customized sorting function, so I can say, well, if you're tied, so we'll automatically sort by the tuples that I've created, but it won't automatically put the bigger one first for the second one. So I've made this customized sorting function, and then I can just go through and say if this one is smaller, if the second item, if the bigger item starts is less than or equal to the end of the first item, then we can know that like it overlaps somewhat. So we know this one starts before the other one ends, and so we just want to detect that, but we also want to detect we want to know that this one was tricky for me to do at the time.
I think you're conflating part 2.
Am I
think,
okay?
Yes, you want to know that whichever one starts second finishes before the first one finishes as well.
That's what I want to say. Yeah, because we know from sorting it that they're already in order for who starts when, and we just want to know if the second one has already ended before we get to the end of the first one. And then we can just add one to the list. So mathematically, we can work that out, which, as you saw, is a little bit tricky on the brain. And it did take me a while to realize I needed to do this customized sorting function. Otherwise, it was not going to catch all of the things. So yeah, that is my alternate option for this one here.
Yeah. I reckon we skip part 2 of this one on the stream, because part 2 of this one is, rather than totally contained within, it just wants you to get the count of, do they overlap at all? So in doing sets, instead of doing subsets, I use the intersection, and if the length of that is more than 0, as in there are some numbers that overlap, then they overlap. And for Renee, who is doing her ranges and maths, you can check the start and end and make sure and know whether or not it has the second one has started before the first one has ended, rather than ended before the first one has ended. And that just gives you the total count of ones that overlap at all.
Yeah, that's it. So I'll just pop them in here. But yeah, just a slight change to the if statements. Yeah, that's it. We don't even need that line. So yeah, that's all there for you to play with later. But yeah, just a slight change to the if statements or to the set maths there. Cool. Let's take a little look at the last one.
Yeah, and maybe because we're now quite a bit over time, we won't show the code for this one, but I do want to talk about the text input that we have here. If we scroll down and see all of this example input here, that looks really scary. It's kind of a mess. It's not really a handy computer format of an input. And this comes back to what I was talking about earlier. So in this problem, all you are doing is you have crates that are labeled with a letter like Z or C or D, and you are moving them between the different columns, in this case, 1, 2, and 3. And we have a number of instructions. So it's like move one crate from column 2 to column 1. So that would move crate D and put it on top of crate N. So as a human, logically, this is actually pretty easy to solve. But it all comes down to the parsing and getting that data in a useful way that your computer can then manipulate it. And here's the secret tip for this one that Renee alluded to earlier. You could possibly just do this by hand. It's pretty hard to parse that function, like to parse that block of initial setup of the crates at the beginning and get that in a data structure that you want. You could just decide what data structure you want and write it out by hand, because that's it's a bit of a hassle to do it for the example one and then for your real one. And your real one is bigger, but I would like to point out, not that bigger. It's only got 9 columns, and it's all capital letters, so it can only be up to 26 boxes total. Oh no, they have repeated letters. Regardless, it's only got 9 columns. They're only about 8 tall at the most. So you could actually just do that by hand, and then your input is just all of these move lines.
Yeah,
and
just
then,
cut it out of your text file. You don't need it if you don't want to.
And then you can parse that, and it's much easier to apply those moves to a data structure that you know has been built correctly because you've done it by hand, because it's not too big. You also know in this case that it's not going to suddenly become bigger for next time unless you can do that relatively easy programmatically, because the input file never changes between part 1 and part 2. You know that in part 2, the crates are in the setup that you have here. You might need to do some other transformation on them, but you know that they are how they are there. And so while I did solve this by parsing that programmatically, because I like that kind of challenge, if your goal is just to get through the days and to push yourself and to focus more on the computational side rather than the parsing side, it is absolutely 100% legit to just input that dictionary or input that list of lists or however you want to store them.
Yeah, absolutely. And just not going to talk through all the code, but just showing you this is a parsing problem. This part of my code is for parsing. And then we're actually going to go and do the moves and move them around. But yeah, it was basically about using a regex to get something out of there, or writing down the exact indexes of where I'm going to, grab parts out of between these brackets, because we don't want the brackets. So we've got to get rid of all of that. And some rows don't have all the data in it. So you need to make sure you're not putting those into your lists and things like that. So getting it in the shape that you want and it's easily accessible and something that you can you configure your brain to understand is the longest part of this problem. But yeah, we will share our code for those ones if you want to have more of a look. And then you can feel free to come and ask more questions for the next episode if you have any questions about part 5.
Yeah, I'm just popping in chat. I'm sure there's a nice way to do this, but I've just popped in chat the link to my repo where I'm doing all of my solutions. If you want to go check out any of my ones they're there as well, and that's where I'll be putting all of mine for all future days as I do them.
We're going to need Sarah to move that one over for us because that's the secret chat. That's it.
No, I also have the YouTube stream open on another thing. I'm viewing this as I'm in it, and so I just stuck it in the YouTube comments.
Fantastic. Okay, I haven't seen it come up yet, but we'll make sure
I'm commenting on myself. I think that's just the stream delay. And anyway, yeah. So my link is in the chat there. You're more than welcome to come and check that out.
Cool. But yeah, that's it for today on this advent of Code Garden. We'll be back on the Australian Friday, Thursday for you in the US. If you're joining us for the next part of our series, where we're looking at the next 3 questions, I believe. However many have come out before then, we'll take a look through those. Yeah, and then also if you're keen, there's the Code Garden Holiday Special. We'll be making magic with microbits with some holiday-themed trinkets made of microbits and lights and flashing and fun stuff with our special guest host, Helen Cardios-Menos. So if you want to see any of those, you can check out my page here that's been dropped by Sarah in the chat earlier up, I believe. So yeah, then you can come along to that as well. Cool. So yeah, that's all we've got for you today. I hope we see you again in the next episode of In the Code Garden to do some more Advent of Code.
We did just have a question of someone's already in a private leaderboard on Advent of Code, and they're wondering if they can join a second one.
Yes,
you can join as many private leaderboards as you wish.
And yeah, you can only have one of your own, but you can join lots of other ones. So great question.
Yeah, you can host one, you can join infinite.
That's it. Awesome. So yeah, thank you all for joining us. Please take the time to do our survey that Sarah's dropped in the chat. We really appreciate when you do that. And yeah, you can watch this video later if you want, and go and jump on the Cloud Skills Challenge if you want some more programming fun to practice with. And we'll see you hopefully in the next episode of In the Code Garden. So yeah, thank you everybody, and have a good afternoon or morning or evening wherever you are.
Yes, thank you for coming along. I hope you learned something. Learn more about sets. They're great. That's my advice.
Do it. Hey, bye everyone.